at molality. Molality is just like molarity. Okay, let's try one. A solution contains 78 grams of salt in 128 grams of water. What's the molality? Give me if you'll pause for a second, we'll come back and work it together. All right, when you work in molality, start with the formula. Moles, solute. Magic word here is solute. What are you dissolving? Well, if I read the question, it says salt in water. So the solute is going to be salt, and it's going to be in kilograms solvent. Now remember, we said solvent's what you're dissolving into, and you're dissolving into water. So basically, you're going to change this into kilograms. You're going to change this into moles. How do I know that? Well, the solute is in moles, and the solvent is in kilograms. So that's what I have to do. Well, this is the easiest one. If you're in grams and need kilograms, back the decimal up 3 times. So this is 0.128 kilograms. So grams to kilograms is the same as doing milliliters and liters. You just back your decimal up. All right, so that means I'm going to have to take the 78 grams, and I'm going to have to change it. Salt, add the weights, 23, 35.5. That's 58.5. So I grab my handy-dandy calculator. 78 divided by 58.5 equals 1.33. So this is 1.33 moles. And so it's simple dividing. So I grab my handy-dandy calculator. 1.33 divided by 0.128. Answer, 10.4. Show you that on the screen again, just to make sure you can see it on my calculator. 10.4. 10.4 molal. Now let me show you how that's said. 10.4 molal. Now it's not written like that really, but since it's molality, that's how it's said. It's just an abbreviation for it. 10.4 molal. It's the same math as you're doing in the other, except it's the difference between the formula for molarity and molality. Let's do one more. Let's do one like this. A 4.3 molal solution is located in 783 grams of water. How many grams of Li2O were dissolved? All right, now about the hardest question I can ask you. So if you'll pause it, give them a chance, and we'll come back and work it together. All right, with molality, again, start with the formula. Moles solute over kilograms solvent. All right, read the question carefully. They're giving me this number. They're telling me the concentration. See the little M? There's the concentration, is located in this much water. Okay, so is water the solute or the solvent? If you keep reading, how many grams were dissolved? That's the solute. So this right here is my X. So that means I'm going to take this, back the decimal up 3 times, 0.783 kilograms, and I'm ready to solve. I put it over 1. I'm going to cross multiply. Those two equal X. And the other two, 4.3 times 0.783 equals 3.4. 3.4 what? Well, 3.4 moles. But the question says how many grams? So I have an answer of 3.4 moles. Railroad track it. Moles, grams. What number goes with moles? Always 1. Grams. Grams of what? They even told me its formula. So all I have to do is add the values off the chart. Lithium has a weight of 7. 7 times 2 is 14. Oxygen is 16. That's a grand total of 30. So this is the right answer if they wanted moles, but they wanted grams, so I'm just changing it. 3.4 times 30, 102 grams. There's my answer. That's about the hardest question I can ask you. Molarity and molality are very similar to one another. The only difference is the formulas look slightly different, but the math is the same. I'm going to give you one quick thing you want to make sure and write down. I'm going to put a star, and I'm going to put it up here. For water, 1 gram equals 1 milliliter. For water, only water, a gram equals 1 milliliter. So let me ask you a question. If I had 783 grams, how many milliliters is that? Well, if 1 gram equals 1 milliliter, that's 783 milliliters. Now, why would that be important? Well, if the question said, okay, now calculate molality, well, then that number, since 783 grams is equal to 783 milliliters, I can now use those milliliters to make liters. So this is sort of a little bridge that will help you sometimes with grams and milliliters, and it's only true for water, nothing else, and that'll sometimes help you. So if they give you a unit in grams and you needed milliliters and it was water, oh yeah, it's exactly the same. Well, you're going to practice some problems with concentration and molarity and molality, and then we'll look at why do we use these and how can they be helpful. You guys are doing a great job. Keep up the good work.